Okay, this lesson is over trapezoids. I apologize if I go too quickly. You can always pause it and fast forward and do whatever. But I just recorded this, and then as it was saving on my computer, it deleted itself. So I apologize if I go too quickly. Okay, so the definition of a trapezoid. So biggest thing with a trapezoid is that this is the first one we've looked at that's not a parallelogram. So it's the first one since like section 1. This is not a parallelogram. So all those 6 things do not apply to this, but we have new things. So with a trapezoid, the biggest thing is it's a quadrilateral that has 1 pair of parallel sides. The bases are those 2 parallel sides. So if you look at the picture over here, this is a base and this is a base. They also do this a lot just to confuse you, where they flip it on its side, in which case this would be a base, this would be a base, and they're parallel. So the next one, the legs, are the ones that are non-parallel. So they're the other 2 sides that are not parallel, and the base angles. Now this is a little bit confusing. The base angles, the one I want to make sure I tell you is that they're the 2 angles that share the base of a trapezoid, but they kind of come in pairs, and that definition says that. But they're all 4 base angles, but these are base angles to each other, and these are base angles to each other. But I think that's a little bit of a confusing thing to realize that there are 4 base angles, but you kind of want to look at them in pairs. So properties of trapezoids, we already talked about this one. Only one pair of sides is parallel. These are called bases. And now this one I added in here because I think it must have gotten deleted when I was editing some things. But the quote-unquote left pair of angles and the right pair of angles are supplementary. Now what I mean by that is the left pair is these 2 add up to be 180. That's the left pair. The right pair, these 2 add up to 180. Now the reason I put them in quotes is because, again, if we have a trapezoid that looks like this, well, obviously it's not left and right anymore. Now it'd be these 2 angles and these 2 angles. So again, I didn't know a better way to describe those, and I thought that was a pretty good way, especially if I put them in quotes, where it's not going to be like that every time, but I think that's a good way to pair those. And again, supplementary means they add to 180. Now these are properties of an isosceles triangle. An isosceles trapezoid. So an isosceles trapezoid is just like any other trapezoid in the fact that the bases are parallel. But the new things are these 3 things. The legs are congruent to each other. So these 2 legs are congruent. That's what makes it isosceles, just like an isosceles triangle, where those legs are congruent. The diagonals are also congruent. So this diagonal and this diagonal are congruent. AC is congruent to BD. Whoops. And the base angles are also congruent. So again, the base angles mean these 2 angles are congruent to each other, and these 2 angles are base angles. They're congruent to each other. And that's why I said you can kind of look at those in pairs that way. So these first 2, we're solving for all these missing angles, but please realize they are both isosceles trapezoids. So everything on the last slide does apply. So angle C is 65, which means angle F is 65. Now to find the other angles, remember what I said, the left angles add up to be 180, so do the right angles. So 65 plus D. If you want to put an X in there, that's fine, is equal to 180. So 180 minus 65 is 115. So that's 115. And again, you can do the same thing with angle E, but it also has to be 115 because if it's an isosceles trapezoid, the base angles are congruent. Now, one really quick way I'd recommend for you to check your work, add all those together and make sure they add up to be 360. It's all calculator work. It's just hitting buttons. It's not hard. That's a really good way because remember, it is a trapezoid, but it's still a quadrilateral. In every quadrilateral, the angles have to add up to be 360 degrees. So this next one, R is 106, which means S is also 106. And then 106 plus Q is equal to 180. So subtract 106. 180 minus 106 is 74. So again, that means the other two are 74. And again, if you want to add all four of those, make sure, again, all four of them, not just these three, you have to add this one as well. They do have to add up to be 360. Now, these next ones are not isosceles, so you have to be a little bit careful with these. So this angle over here is not 50 degrees. They are not congruent because it's not isosceles. However, these two left angles add up to be 180 degrees. So 50 plus question mark is 180. That question mark is 130. This next one, angle A and angle C. Again, I think a lot of people are going to miss this because they're going to say A is 55 and C is 95. And if this was isosceles, you would be right. If not isosceles, 95 and this question mark have to add up to be 180. Supposed to be question mark. Subtract 95. 180 minus 95 is 85. This one's 85. Then angle C, same thing with these two angles. 55 plus C is equal to 180. 180 minus 55 is 125. Last but not least, again, same thing with those. We know all four angles, so we can make sure they add up to be 360. We can't really do that with this one because we don't know angle X and Y. So this one we have a lot of information to find, but they do tell us it's an isosceles trapezoid, so that means 15 and X are congruent. So that one should be an easy one. BD, so this one's 3 and this is 17, so BD, the whole thing is 20, and that's got to be congruent to AC is also 20, because again, in an isosceles trapezoid, the diagonals are congruent. Then we go on where ABC is 100, so ABC is this one, is 100. What is DAB? So it's this angle down here. Well, again, B and A have to add up to be 180. That means that's got to be 80. Then what's BCD? BCD has to be 100 because, again, isosceles triangle means that those base angles are congruent. So the next thing we're going to talk about is called the midsegment of a trapezoid. And the midsegment is the segment that joins the midpoints of the trapezoid's legs. So if we have a trapezoid here, if you find the midpoint of this leg and the midpoint of this leg and you connect them, that's the midsegment. Now the formula to find the length of that midsegment is 1/2 base 1 plus base 2. A lot of times I do it this way instead, base 1 plus base 2 divided by 2. But really you're just finding the average of the bases. So it's the midpoint of the two legs, but the average of the bases is how you can find the length. So we have a couple of these that we're going to be finding. Sorry. So these first two shouldn't be too bad. 42 and 14. 14 plus 42 divided by 2. 14 plus 42 is 56. 56 divided by 2 is 28. So this length is 28. Not too bad. Same thing over here. 20 plus 12 divided by 2 is equal to 32 divided by 2, which is 16. Not too bad. Just finding the average of those. Now this is where it gets a little bit more complicated because we know the midsegment. We don't know what that base is, that question mark. So we have 16 plus whatever that question mark is. If you divide that by 2, that's 27. So I just plugged it into the same formula we've been using. I just don't know what you're adding to the 16. So from here, now we need to solve this one. Now we multiply both sides by 2. 16 plus that question mark is 27 times 2 is 54. Subtract 16. Whoops. Not divide. 54 minus 16 is 38. So if you want to double check your work, take 16 plus 38 divided by 2. That ends up being 27. If you do that in your calculator, just make sure you use parentheses. Same thing with this one. 61 plus question mark divided by 2 is 40. So multiply both sides by 2. Get rid of that fraction. 61 plus question mark is 80. 80 minus 61 is 19. This is 19 up here. And again, if you take 19 plus 61, then divide that answer, 19 plus 61, take that answer divided by 2, it should give you 40. It does. So these next ones are the same exact math, except for now we have some more algebra to do. Well, again, don't make it harder than it is. These two bases added together, x plus 3 plus 12. Then we're dividing that by 2, and that's got to be equal to the middle one, 3x. So if you want to combine like terms, that's not a bad idea to make this 15. I'm going to kind of do that, again, since I've already done this once. I'm going to multiply both sides by 2, and since that cancels, now is where I'll combine my like terms, just to save myself a little bit of time. Then subtract the x. 15 is equal to 5x. Divide both sides by 5. Your x ends up being 3. But here's the deal. They don't tell you to find x. They want you to find EF in the trapezoid. So once you find that, you still need to plug that in. 3 times 3 is 9. So that's what EF is in that one. Now again, I know there's a lot of stuff going on with this, but again, don't make it harder than it actually is. You're just plugging these numbers in. 7x plus 4 plus 4. Divide that by 2. That's the formula. Then that's got to be equal to the middle one, 3x plus 5. Now with this one, just be careful, because when you multiply both sides by 2, we get 7x plus 8 when you combine the like terms. But then this 2 gets multiplied by both of those. A lot of people forget that. That's got to be 6x plus 10. Then again, from here, let's solve this like normal. X plus 8 is equal to 10. X is equal to 2. But that's not your answer. We need to plug it in. 3 times 2 plus 5. 6 plus 5 is 11. Now you could plug your 2 into this one as well and figure out what all 3 of those bases are and then do the math to make sure you double check. But you certainly don't have to. If you have any other questions, make sure you're letting me know. And let's hope that this saves correctly this time.